Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nobalkis binti Muhammad Shahrudin. My project today are product improvement for aircraft seat part arm cap for product realization subject. My supervisor industry Muhammad Nur Hadi. Introduction. Aircraft interior component affect safety, comfort and durability. Seat arm cap protect sharp edge and seat mechanism. Component experience repeated passenger contact. Component exposed to vibration and cleaning chemical. Failure of small part affect overall cabin quality. For project background, ARMCAP installed on passenger seat armrest. Part support body weight during sitting and standing. Part exposed to cyclic loading every flight. Existing ARMCAP show visible damage during maintenance. Maintenance record show repeated replacement. Observer issue in service. First, surface crack on contact area, fracture near mounting point, loss of flexibility over time, material hardening after long usage, and reduced passenger discomfort. So for problem statement, first one is existing rubber arm cap fail under operational load. So and failure occur deep side, fire safety compliance, design focus on shape replication only, material selection ignore mechanical aging. Frequent replacement increase maintenance costs. For improvement, simple duplication does not solve the failure. So design must address stress concentration, material must resist fatigue and aging, improvement must follow structured engineering process, product realization provide systematic solution for this part. Objective of the project. First one is to identify the critical failure area and the dominant failure mode of the existing aircraft seat arm cap through inspection and analysis. Second, to reverse engineer the original arm cap using 3D scanning in order to acquire precise information about the geometry of the original arm cap. Third, through redesign the geometry of the arm cap in such a way that the stress concentration is reduced. The distribution of the load is enhanced and the mechanical durability is improved. Fourth, to choose DP18263 UL 94V0 material on the basis of its mechanical strength, resistant to cracking, egging, and fire safety. To manufacture a prototype ANCAP on the basis of the redesign, geometry, and the selected material. To perform verification and validation through form and fit and functional testing. To use product realization tool in the entire process of designing the product. So for the scope of the project, inspection and measurement, the original AMCAP, 3D scanning and CAD reconstruction, design improvement without interference change, material selection using technical data sheet, prototype fabrication and testing activity have been done. Product realization overview, structural approach from requirement to validation. Each stage linked with document output. Requirement guide design decision. Verification check design accuracy. Validation confirm functional performance for each object. Requirement identification, durability under repeated passenger load, stable feasibility during service life, compatibility with existing seat structure, compliance with fire safety standard FAR 35853, ease of manufacturing and replacement process. So for this project, study of existing arm cap is a must. Visual inspection show crack pattern, crack concentrated at sharp edge, thin section found near mounting hole, material stiffness increased with age, finding use as redesign reference. Failure cause analysis, which is high stress concentration at edge, Arab geometry transition, material fatigue under cyclic loading, environmental exposure accelerate degradation. and design and material both contribute to failure. So for 3D scanning process, the first one is non-contact scanning used to avoid damage, complex surface captured accurately, full external geometry recorded, data converted into point cloud, and high accuracy support redesign work. So based on the picture, I do the 3D scanning process. So for CAD reconstruction, the first one is we must do noise remove from scan data and surface smoothing performed. Solid CAD model generated and dimensional verify again physical part. Model used as base of for improvement. So for this, we have design improvement strategy. The first one is focus on high stress region only, increase thickness at critical area, and smooth edge reduct. Improve surface contour for comfort, preserve original interference geometry, reduce sharp corner, more uniform wall thickness, better load transfer path, and lower stress concentration, improve tactile feel. We have to do material selection criteria. The first one, fire safety compliance required. Resistant to crack indentation, stable mechanical properties over time, compatibility with manufacturing process, acceptable surface finish quality. Fire safety compliance required to follow the FAR 25 rules. So for after the selected material, we choose DPI 8263 UL94V0, self-extinguishing fire behavior, improve fatigue resistance, better edging stability, suitable for aircraft interior use. So for those plastic part, we used to choose these materials because it's compliance with our FAR 35 standard. And also the strength is a good for aircraft plastic part. Prototype manufacturing. So after we redesign and do the CAD process, we need to do prototype manufacturing. Prototype produced from redesigned CAD. Material process based on supply data. Dimensional accuracy prioritized. Surface finish inspected. Prototype represent final design intent. For verification and validation activity, the first, dimensional measurement against CAD. From and fit check on seat structure. Mounting alignment inspection. No interference during installation. Interface compatibility confirm. Repeated loading to stimulate passenger use. Observation of surface condition. Monitoring for crack indentation. Assessment of flexibility and comfort. Performance stable through testing. Result product performance, material performance. So improve load distribution observed. Mounting area remain intact. No surface crack detected for that part. Handling during installation improve. Overall functional performance increase. Fire safety requirements satisfied. Material retaining flexibility. No visible aging effect after testing. Surface quality remain consistent, suitable for long-term service uses. Durability analysis. Lower stress level at critical zone. Smooth geometry reduce fatigue risk. Material resistant. Cyclic loading. Weight increase control. Maintenance interval extended. Product realization impact. Clear traceability from problem to solution. Reduce redesign risk. Better documentation for quality assurance. Balance safety and durability needs. Effective for legacy aircraft component part. The conclusion, product realization approach successfully applied. Design improvement address root causes. Material upgrade enhance durability. Prototype meet form, fit, function requirement. Improve arm cap suitable for operational use. Recommendation for this project is long-term fatigue life testing, external environmental exposure testing, detailed ergonomic evaluation, and cost analysis for production scaling, apply method to other cabin part that we can create.